Hey, it's Dr. Brad with some awesome, exciting news from space. First off, taking a look at new images and data from the James Webb Space Telescope. One of the beautiful images released is of the Cartwheel galaxy, but also near and dear to my heart, some colleagues have been finding supernova, exploding stars, with the James Webb Space Telescope. So when we look at the image from the James Webb of the Cartwheel galaxy, now what the James Webb can do is look into the infrared colors, and this actually sees through dust. Dust blocks visual light, the things we can see with our eyes. And by looking through the dust, we can see where stars are actively being born. And so when we look at this beautiful image, specifically kind of the redder areas, these are all areas that have been previously invisible to telescopes on the ground in Hubble, but now we can see where lots of new stars are going on. And we think this entire galaxy, the Cartwheel galaxy, is caused by what we call a galaxy collision. Yes, galaxies collide, and in this case, we think a smaller galaxy kind of passed through the center of the bigger one. And as it did, it triggered this ring, the shock wave, to go out into space. And as that shock wave went through kind of the outside ring, it triggered new stars to be born. And when we look at the rest of the parts of the image, when we see a lot of this red stuff, these are, again, new stars being formed that were invisible previously in the Hubble Space Telescope images. So some cases, they're brighter in the image from James Webb and fainter almost in the image from Hubble. But we also get the reverse in some cases. When we look at specifically areas where there's lots of old stars don't have a lot of dust, therefore we kind of see them naturally in the optical colors. They're not as bright in the infrared colors. And so in fact, this kind of bluer galaxy that we see in the James Webb image, when we look at the Hubble image, you can kind of see this difference. And in fact, when we look at specifically just the infrared color, you can see that it's almost entirely gone, meaning no new stars or very few stars are actually being born here. But as I said, James Webb has also gone the other end of the spectrum, looking at the deaths of stars. Now, one of the big ways we do this, and the main way, is we play spot the difference. We take an image of a galaxy or an area, and then we take a new image, and then we subtract them. We match up the brightnesses, we subtract the difference and see, is there anything new and bright in the newest image that wasn't there in the previous one? And lo and behold, what the James Webb has already seen from the very beginning data is some of these new exploding stars, as you can see here. And this is why I'm really excited, because if we can find really, really far away and old stars, we can learn a lot about the first stars as they're formed, but also how the universe has grown. We can use these exploding stars as tools to measure the growth of the universe. This week has also been a huge week for space missions. Firstly, as reported here, the debris found in the snowy mountains of New South Wales in Australia, the debris has been confirmed by SpaceX, and they are headed out this week to investigate, and we'll obviously bring you up to date as they evolve in this situation. Now, NASA's Artemis 1, this is NASA's return to the moon mission. A date has been set. Yes, NASA's first mission on its way to sending humans back to the moon is scheduled the 29th of August US time. Now, there won't be humans in this. This mission will go around the moon. They will test all the various systems. They will have a dummy on it, Moonican Skywalker, and it will eventually come back down to Earth. So the whole mission time will take well over a month, but if all goes according to plan, then Artemis 2 will start sending humans around the moon. Now, NASA has also outlined their plans for getting samples back from Mars. Now, this has been a big goal of Mars. How do we get these samples that we've been analyzing and studying and hopefully, or maybe, have evidence for life back down to the Earth? And we have to think now Ingenuity. Yes, Ingenuity, that drone that's been flying on Mars that a lot of people were unsure whether it was going to work due to all the technical challenges, the atmosphere, all that sort of stuff, has performed so well. NASA says, we're all in on Mars drones. They're going to use 2 drones to help collect the samples and bring them back to essentially the rocket that will then return to the Earth, hopefully in 2033. So we're going to have to wait for this one, but we're going to be seeing more drones on Mars. But there's also a lot of activity around the moon. South Korea has sent their first mission on a SpaceX rocket to the moon. The Korean Lunar Orbiter, or Danuri, will go in orbit around the moon doing lots of different scientific experiments. And this hopefully will pave the way so that Korea can land their first rover on the moon by the end of the decade. Now, as we brought to you a couple of weeks ago, there was this Chinese rocket booster, the Long March 5B, re-entering the Earth's atmosphere before the SpaceX junk. Well, that did come down. It appears that no one was injured. It eventually landed in the ocean west of the Philippines. So luckily, that was a success to some degree that no one got hurt. But as we've seen, space junk is obviously becoming a problem through lots of groups and countries. And in an unfortunate incident, the Indian Science Research Organization, ISRO, had a failure in one of their launches in the past week. Their rocket went up, but a malfunction in one of the boards essentially put the satellites in the wrong orbit and the path, meaning that they never reached the exact right orbit and destination that they wanted to, meaning that the satellites have now been lost. It's a devastating blow for India, but, we always sometimes hear more about the failures, but India's had so many successes in their space program. We can be sure they'll fix the problem, bounce back, and be launching again in no time soon. And if the day feels like it's been a bit shorter, well, it is. And kind of in this last story, we're talking about time and the fact that scientists have been measuring that lately, the Earth's day is actually a bit shorter. We're spinning a bit too fast. So how do we all know this? Well, we measure time using atomic clocks, using the pulse of what we call a cesium atom, something that pulses and vibrates hundreds of thousands of times per second. We use this as a very accurate, very fraction of a millisecond stopwatch. And what we do is you can kind of measure how many pulses or how many times the cesium atom does it in one revolution of the Earth a day. And now this is very important because what we would normally perceive as the day, us spinning around 24 hours and the sun rising and setting and stars going through our sky, is actually not a perfect day. We've actually known this for decades. One of the biggest discoveries of the Apollo mission was they left these lunar reflector plates all over the moon. And what scientists have been doing is bouncing lasers off those plates and back to the Earth. And knowing the speed of light very accurately, you can measure how far away the moon is by essentially this speed stopwatch. And what we've now known is that over time, the moon is actually drifting away. On average, the moon is about 4 centimeters further per year. So as the moon drifts away, our day actually slows down. This tug-of-war of gravity between the Earth and moon and the sloshing essentially of the oceans on us as the moon's drifting away, we've been slowing down. So we've actually been having longer days. And so to account for this, scientists have been adding what we call a leap second. Every few years, they add a second to the clock in order to account for this distance. But now all of a sudden, for about the past year, and specifically the past month, our days have been spinning too fast. They've actually been shorter. So there's talk that we may actually have to take away a second. Now, if this is all confusing, it's actually an interesting part of research. Trying to figure out exactly why now our Earth is spinning up is unclear. We do know it has something to do with this sloshing, right? A lot of liquid on the surface, more solid on the inside, a liquid core. There's a lot of these sloshing effects. Could do with the distribution of water in the ice caps. It's actually a fairly new phenomenon that scientists are trying to get a handle on, but it's a very important one. If we don't correct for these differences in time, eventually over years, our clocks may be so far off that sunrise is now at 4 a.m., not 6 a.m. So it can be very important for us on Earth, and things like atomic clocks are needed for GPS systems and even the internet. So really great that a lot of people are working on this, but I wouldn't lose any sleep over it. I hope you enjoyed this update in space. Make sure to like and subscribe on YouTube to stay up to date.